What you're seeing here is 3D Gaussian splatting, a PLY file containing 1.07 million 3D Gaussians rendered live in pure CUDA C++ in a pipeline I built. Each Gaussian is fully specified: a world space position, a unit quaternion for orientation, 3 log scale axes for the ellipsoid, an opacity logic, and 48 spherical harmonic coefficients for view-dependent color. The PLY file hands these directly to the renderer. Per frame, 6 CUDA kernels calculate the following: spherical harmonics for view-dependent color, EWA elliptical weighted average projection, which composes of a world camera to camera rigid transformation, rotation plus translation, a perspective projection divided by depth, and then the Jacobian is calculated for the push forward of the 3D covariance matrix into the screen space conic, the projected ellipse. Then 2 pass tile intersection, bin the Gaussians to tiles, cube radix for sort by depth, front to back order, intersect offset, and an alpha blended tile rasterization. Code has been verified by 84 unit tests. We've re-implemented gsplat CUDA kernel stack in pure CUDA C++ in order to avoid the heavy memory footprint of Python and PyTorch.